Hello students, through this video we are going to study last experiment of the subject power system analysis, and title of the experiment is to study equal area criteria for transient stability by using MATLAB software. So from the title of the experiment it is clear that before going to study this experiment you should have the idea what is meant by the stability of the power system and what is meant by the equal area criteria method, and then we will study this concept by using the MATLAB software. So title of the experiment is to study equal area criteria for transient stability by using the MATLAB software, and aim of the experiment is similar to the title, and apparatus is nothing but you should have the MATLAB software installed on your PC. So before going to start the experiment, first of all we'll discuss about the basic point, that is what is meant by the stability and what is meant by the equal area criteria. So if we discuss about the power system stability, then the stability is nothing but it is closely related with the synchronism. That means after the occurrence of the different type of the fault, if your system remains stable or it remains in synchronism, then we can say that the power system stability is present. But if the occurrence of the fault, if after the occurrence of the fault the system becomes unstable, then we can say that the power system stability is absent in case of the system. So if there is, that means if there is a loss of synchronism, we can say that there is a loss of stability. So definition of the stability is nothing but ability of the synchronous machine or part of the system to develop restoring forces equal to more than disturbing forces so as to remain in synchronism. And what is meant by the different type of the disturbances? Disturbances are nothing but sudden change in the mechanical load. That means if there is either increase in the load or decrease in the load, then there is sudden switching, then sudden change of the power swing, etc. As well as we can say that the different, suppose there is sudden short circuit on the transmission line. These are called as the disturbances. But if after the occurrence of the disturbance, if your system regain its original position, then we can say that the system is stable. Now, if we go through the standard definition of the stability, then power system stability is the ability of an electrical power system for given initial operating condition to regain a state of operating equilibrium after being subjected to physical disturbance, with most system variables bounded so that practically the entire system remain intact. Now, if you go through the classification, the stability is classified as steady state stability, dynamic stability, and transient stability. But since in this experiment we are going to study the equal area criteria for transient stability, that's why we'll discuss steady state stability and dynamic stability in short. So what is meant by the steady state stability? In case of the steady state stability, the limit of particular circuit of power system is identified as maximum power that can be transmitted to the receiving end without loss of synchronism. And if we consider the disturbances in this type of the stability, normally the steady state stability limit does not take severe turns to collapse the system and has a comparatively large limit. That means the disturbances are having less impact on the system, and that's why that if we consider the protection provided, the sensitivity of the protective devices is less as compared to the other type of the disturbances. Now, in case of the dynamic stability, this stability comes into the system when load is frequently changed and has no specific amplitude. And if we consider the time duration of the fault, dynamic stability can be carried out for 5 to 10 seconds and sometime up to the 30 seconds. That means this time duration is more as compared to the steady state stability, but less as compared to the transient stability, and the stability has comparatively lower value than the steady state stability limit. And the next point, that is transient stability, which we have to study under this experiment. This type of the stability come into the picture whenever there are a different type of the disturbances which are having more severe impact on the system are present. That is, this type of the stability is known as the transient stability, and it's fast phenomena usually occurring within 1 second for generator close to cause of disturbance. That means time duration is very less as compared to the steady state and dynamic stability, and hence the sensitivity of the protection which is required in this system is more, and that's why the cost of the protection which is provided in case of the transient stability is also more. So what is the method to decide the transient stability? In this case, actually there are two different methods. First one is the equal area criteria method and second one is the point by point method. So what is the difference between the two methods? In case of the equal area criteria method, we decide the critical clearing angle, that is the value of rotor angle del which is required to decide the stability, and critical clearing angle is nothing but it is the maximum angle rotor angle swing after the occurrence of the fault at which our system can remain stable. So that critical clearing angle can be decided with the help of the equal area criteria, but the limitation of the equal area criteria which can be covered by the point by point method is that with the help of the point by point method we can calculate the critical clearing time also. So what do you mean by the critical clearing time? It is the maximum time duration for which if the fault is present then also your system is remain stable. So now we'll discuss about the equal area criteria. So what is the procedure in case of the transient stability? What we do, we list out the different type of the fault which can be considered under the transient stability, and then we decide whether your system is stable or not. So in case of the transient stability, mostly we consider the different type of the severe faults like sudden change in the mechanical input, effect of the clearing time on the stability, sudden loss of the one of the parallel line, then sudden short circuit on one of the parallel line, etc. So such severe faults are considered, and for which we plot the equal area criteria and then we decide the stability. So what is meant by the equal area criteria? As the name suggests, equal area criteria, that means it is related to the two area should be equal. So which two areas? In this case, if we go through the derivation of the equal area criteria, at the end we get the derivation integration del 0 to del pa d del is equal to 0, then your system is stable. So in this case, two areas are nothing but area under the accelerating power, that is area of acceleration, and second one is the area of deceleration. So if when area of acceleration is equal to area of deceleration, then your system remains stable, and that's why this criteria is called as the equal area criteria. So now we'll discuss what is meant by the acceleration area and what is meant by the deceleration area. It is observed that whenever generator is used to generate the power, at that time there are two types of the powers are present. First one, mechanical power input to the machine, and second one, electrical power output by the machine. So when Pm is greater than Pe, at that time that condition is called as the machine is going to accelerate, and area on power angle curve, that is area with respect to the electrical power output and rotor angle del, then that area is called as the area of acceleration. Whereas another condition, whenever mechanical power input is less than electrical power output, then the machine is going to decelerate. So area under this condition is called as area of deceleration. And generalized equation for electrical power output, P is equal to P max sin del, where del is nothing but rotor angle del. So from the equation it is clear that whenever del goes on increasing, your electrical power output goes on increasing, but it is maximum when del is equal to 90 degree. So from till now discussion, it is clear that when area of acceleration and area of deceleration on power angle curve are equal, then system remains stable, and that criteria is called as the equal area criteria, and equal area criteria is used to determine the transient stability. So now this is the basic prerequisite which is required to study this experiment. Now we'll go to the actual experiment. That is, we have to study the equal area criteria by using the MATLAB software. So for that purpose, what we'll do, we'll consider one simple system. Then we'll plot the equal area criteria by using the MATLAB software, and then we'll discuss about the result. So what is the example? The machine is delivering a real power of 0.6 per unit at 0.8 power factor lagging to the infinite bus bar, and the infinite bus bar voltage is 1.0 per unit. And we have to determine the equal area criteria for two cases. In case A, the maximum power input that can be applied without loss of synchronism. This point we have to determine. And in second case, similar, we have to repeat the A with zero initial power. That is, what is the difference between case A and case B? In case of the case A, initial power is 0.6 per unit, whereas in case B, the initial power is 0. And assume that the generator internal voltage remain constant with value computed in A. What is the other information is given? The transfer reactance and generator internal voltage found to be X is equal to 0.65 per unit. That is, transfer reactance is 0.65 per unit and E dash is 1.35 per unit. That is, transfer reactance and generator internal voltage are given. That means in this experiment we have to plot the equal area criteria graph for two cases, and then we have to discuss about the result. So in first case, if we go through the input parameter are nothing but P0, that is initial power is 0.6, E, that is generator voltage is 1.35 per unit, then voltage is 1.0 and transfer reactance is 0.65 per unit, and we have to plot the equal area criteria by using the MATLAB software. So the program, in case of the program for equal area criteria, there is command AAC power, that is P0, and program is AAC power P0, E, P, X. Now the main important thing is that whenever you are going to run this program, make sure that this AAC power program is, the M file including the AAC power program is available freely on Google software. So before running this program, you have to download that M file from the Google and you have to save that file on the desktop, then only this program will run. So I am already having this M file which is saved on my desktop. So I have saved this AAC power.m file, then only your program will run. So what I will do now, I will try to run that program, that is for the first case in which initial power is 0.6 and I have to obtain the equal area criteria graph. So I had already written this program for first case that will discuss. That is, program is nothing but we have to give the input parameters of P0, E, Phi, X and this command AAC power. So if I will run this program, then I will get the equal area criteria graph, and which is nothing but power angle curve, that is curve between the electrical power and rotor angle del. So this is the equal area criteria for the first condition, that is whenever the initial power is 0.6 and there are two areas, area of acceleration and area of deceleration, and you can save this image by save as option, and you can save this image as bitmap image. That is, through this option you can save it as a bitmap image for write-up purpose. But if we have to go through the detailed parameter, then in command window you will get the output parameters for this graph, that is initial power is 0.6, but is the initial power angle 16.791, that is del 0, and due to the disturbance sudden additional power is 1.084, that is sudden, we are going to study the disturbance of sudden change in the mechanical power under the transient stability concept. So total power for the critical stability is 1.684, and maximum angle swing for this uh, system to remain stable is 125.840, and new operating angle is 54.160. Okay, so this is the information by the equal area criteria for this case. Now what we'll do, we'll repeat the same procedure as per the example, but we have to, in second case, we have to change the initial power to 0. That is, in first case the initial power is 0.6, but now we have to repeat it with initial power 0. That is, the program is similar to the first case, but only changes that initial power is changed from 0.6 to 0. Now I will plot the equal area criteria by using the MATLAB software. So this is the equal area criteria for the case B, and if we go through the parameter, then from the command window we'll get the idea about the second case parameter. See, in this case initial power is 0. Since P is equal to P max sin del, initial power angle is also 0. Then sudden additional power is 1.505, which is less as compared to the first case, because in this case initial power is 0, and maximum angle swing is also maximum angle swing in this case is more as compared to the first case, that is 133.563. That is, your system can remain stable up to this maximum angle swing, and new operating angle is less as compared to the first case, because in this case initial power is 0, which is 46.437 degree as compared to the first case 54.160. So thus by using the MATLAB software we had obtained equal area criteria for both cases, and if we go through the comparison, it is clear that in first case initial power is 0, in 0.6, in second case initial power is 0, remaining parameters are same, and if we plot the equal area criteria, then it is observed that in first case where the initial power is present, initial power angle is more as compared to the second case, then sudden additional power is less as compared to the second case, then total power for the critical stability is more as compared to the second case, and maximum angle swing is less as compared to the second case, whereas new operating angle is more as compared to the second case whenever initial power is 0. Thus, conclusion of this experiment is nothing but we study the concept of equal area criteria, we study the concept of the transient stability, and we try to understand how the equal area criteria is useful to determine the stability, and how we can study the equal area criteria by using the MATLAB software. Thus, we see the use of MATLAB software for the power system analysis purpose. So, with this, there is end of the 8th experiment. Thank you.